Hey everyone, I'm going to be going over question 80 from the chapter 6 bingo questions. And this problem has to do with this physics professor being pushed up a ramp at 30 degrees. So we draw a little ramp. It's a pretty steep angle, not to scale, but anyway, this teacher is being pushed up on a chair, and we know the velocity at the bottom, which is, the initial velocity since they're going up, is 2 meters per second. The distance that they're covering, 2.5 meters, total mass 85 kilograms. And that total mass is just the mass of the teacher and the chair that she's sitting on. They want to know the speed at the top of the ramp using the work energy theorem. So I've already written down some of our equations that we can use. So the work equals, the change in kinetic energy. And then I also broke down the work into the different components of the force times the distance. And so now what we need to do is just use all that and kind of put it together to find what we want. So to do that, the way I found out to do would be to use this and combine it with this. So we'll get F equals, and then we're going to do this and combine those together. So really it's all of these combined together. So that's why I wrote them out beforehand, just because it's a lot of equations. So okay, so we have our really long equation now. And what we're looking for is the velocity, the final velocity, right? Because we're starting at the bottom, we want to know what it's like at the top. So now what we need to do is solve for that final velocity. And of course, these angles, these thetas, are going to equal to 30 degrees. And so let's just plug it all in. So the force is 600 newtons. Times cosine of 30 minus the mass, 85, gravity, sine 30 times all that times by the distance, which is 2.5 meters. And then all that equals 1/2 times 85. F squared minus 1/2 85. 2.0, because that was our initial velocity. And honestly, I just threw that in my calculator because it was so much that I just did all of this side and then solved it from there. And then of course you need to take the square root, and so what I ended up with is, well, first of all, so VF equals 10.04 meters per second. Oh, that's squared. And so the final meters per second. So at the very top of the ramp, with the force that she's being pushed with, she ends up going 3.17 meters per second. So I kind of went through this fast, but basically we just use the equations that we have. We break the force into the components since we have an angle. So of course, we need the cosine and the sine. And we combine all of these together in order to be able to solve for that final velocity. So, hope you learned something. We'll see you in the next video. Thanks.